Okay, one of the most common ways to describe data is through the use of frequency distributions. A frequency distribution is simply a table that organizes the number of data values into intervals. The intervals in a frequency distribution are known as classes. And we'll talk about that. We'll do examples. And the number of observations in each class is known as class frequency. So for example, I have, excuse me, are we not interested in the lesson? Thank you. Okay, so people with black hair, this is a bar graph. People with brown hair, maybe you have, right? You did 25 people have black hair. 30 people might have brown hair. Right? So these are your frequencies are here, and your categories or numbers are down here. Okay, classes should be of equal size. Try to have no fewer than 5, so you should have 5 to 20 classes, no less, no more, approximately. Too few or too many classes tend to hide the true characteristics of your frequency. So these are the rules we will follow by. Again, I tell you it's not an exact science, but I need to be able to mark you according to certain standards. So these are the standards we'll use. Determine a reasonable class size taking the range of your data into consideration. Make sure classes are mutually exclusive. For example, you don't want 2 classes to be 3 to 5 and 5 to 7 because you don't know where the 5 goes, right? Does the 5 go here or does it go here? Alright, some textbooks use the 0.5 rule. I find that a bit much. I don't like it. Don't avoid using open-ended classes. For example, highest class of 15, like don't use or over. They have to have a definite size. Include all data values from the original table in a class. In other words, all your values should be able to be observed on your frequency distribution. That's frequency distribution. Another way is relative frequency distribution, and it's basically the percentage of the observations in each class. Cumulative means we're adding them up. Here we're adding up the relative, and I'll show you that. Histograms and bar graphs. The only difference between a histogram and a bar graph is on a histogram it's joined together. This is your histogram. And on a bar graph they're separate. Okay. So here you have continuous data. Remember, continuous data is data that's derived from a measurement. This is good for discrete data or categories. So discrete data is data that comes from a count. And the black hair, brown hair is your that was an example of categories on a bar graph. Okay. So a histogram, the bars are connected and represent a continuous range of data. Whereas bar graphs, okay, so maybe we'll just go over this. Histograms are used for variables whose values can be arranged, such as weight, temperature, travel time. Notice these are all the result of a measurement. For temperature, you need a thermometer. For weight, you need a scale. For travel time, you need a clock. Frequency polygon is a graph that uses lines instead of the boxes. I'll do examples on that. Bar graphs are similar, but the bars are separated. They include frequencies of separate categories in no set order, such as hair color. It can also be superimposed on a bar graph as well. Let's start with the examples, okay? The following table represents the number of calls each day during the month of May on John's account. Construct a frequency distribution, a relative frequency distribution, and a cumulative frequency. So we're going to do a frequency distribution, a relative frequency, and a cumulative. Oh, okay. It's just that you look so interested. All right. It looked like you were very interested in something. Okay. Anyway, let's do it. The first thing we have to do is calculate our interval size. So we're going to calculate an interval, a decent interval size. We have to decide what to use. So we have to remember, we first take into consideration our range, as I discussed before. Okay, so our range is 15. That is simply the biggest value minus the smallest value. This is calls per day. If we using 5 to 20 intervals as the correct number of intervals, let's see, the largest interval size would be well, if we take our range of 15 divided by 5, we get 3, and then our smallest interval size that would be acceptable would be 15 divided by 20, which is 3/4. Do you see what I've done? We're using a range, right? We're using 5 to 20 intervals. So if we used 5, our interval size would be 3. If we used 20 intervals, our interval size would be 3/4, which doesn't make sense, really, right? So, what should we do? Should we use an interval size? 3 seems reasonable. Why not? You could use anything between 3 and 3/4 and 3, but why not use 3? So we'll go 0 to 2, that's 0, 1, 2, right? There's 3 there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I'm not going to make you count. We could count, but do you trust me if I say between 0 and 2 there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Where's 12? So 12. Okay. So between 3 to 5 there's 8. Between 6 to 8 there's 5. Between 9 to 11, 13. Between 12 to 14, 1. Between 15 to 17, 1. Our total is 30. What's wrong? Oh yes, something's wrong. Oh, what did I do? Oh, this should be 3. That's... Yeah. No, that's me having an overheated senior moment, I guess. Okay. All right. So let's do relative frequency. So again, we're doing 0 to 2. Those are good intervals. So this is going to be 12 divided by 30. That's relative, right? You divide by the total, and that's 0.4. That's relative to the total. It's 0.4 or 40%. So 3 to 5 is 8 over 30, and that's approximately 0.27. 6 to 8 is 0.17. It's just 5 divided by 30. 3 divided by 30 is 0.03 or 3%. No, that should be 10%, right? That's 10%. Uh, 12 to 14 is 1 divided by 30 is 3%, and that's 3%. And this usually adds up to 1, but sometimes it doesn't because of rounding. Okay, that's relative. Cumulative frequencies, we add up the frequencies so you get a running total. So on the first one we have 12, then we do a running total. 12 plus 8 equals 20, and then 20 plus 5 equals 25. And you just, then 25 plus 3 is 28. 28 plus 1 is 29. 29 plus 1 is 30. That adds up to 30. That our total is 30, right? And it should be. Well, we don't want to total it. Sorry, we don't want to total that guy. Forget that. Yep.
Should the cost per day in the common cumulative frequency distribution be 0 to 2, 0 to 5, 0 to 8, or should it follow the original?
I think we leave that just to indicate that the 20th is in the.
But there are 20 frequencies
Yeah.
of 0 to 5 cost.
Don't worry about that kind of accuracy. Yeah. I think this gives us more information than if we did, 0 to 17.
But
Right.
technically, if you
Yeah,
want the
yeah.
right to correspond to that,
Yeah,
you should
yeah,
go
yeah,
from 0, right? 'Cause it's
yeah. But they usually don't write it that way. But I hear you. Okay. When you do a chart, you have you need to put a title. That's worth half a mark. You need to label your axes. So this is number of days. That's worth half a mark. This is calls per day. That's half a mark. So we'll start here. We'll go by twos. 2, 4, 6, 8, 10, 12. So they want a bar graph. Okay. So this is really discrete data, so it's okay. Notice your variable is discrete. It's based on counting. I'm going to write it like this. This is going to be 0 to 2. Then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Are you signing out? Yeah, okay. Okay, from 0 to 2 we have 12, so your pencil might be easier. You're shading in all of this. 3 to 5 is 8. 6 to 8 is 5, so that's going to be right there, halfway between the 4 and the 6. Then we have 3. And then we have 1 and 1. So all we can say is John here, usually he only has 0 to 2 calls per day. He doesn't seem to get too many calls. Maybe he's not working hard. I don't know. Okay, so it also says superimpose a frequent. So make sure you bring a ruler to your test. When's your test? October 4th? Okay, so we're superimpose. This is a polygon. A polygon has sides, right? Frequency polygon. Good? Shh. Are we good? Can I explain anything better? So remember, half a mark for this, half a mark for this, half a mark for this, half a mark for your scale. So if a diagram on a test is worth 4 marks, 2.5 go to your labeling and titles. Okay, let's do the weights of 30 female students. Yeah? Yeah. Do you remember the definition of a polygon is a many-sided figure with straight lines? So the polygon is just these dots with straight lines joined together.
But it isn't a closed polygon.
No, it's not closed. It's pretty open if you ask me. Are we good? Yeah? It's not rocket science, is it? The weights of 30 female students majoring in biology on a college campus are given below. Summarize the information with the frequency distribution, a relative frequency distribution, and a cumulative relative frequency distribution. Okay. So let's again consider how we're gonna, what classes to decide on. You always consider your range. So that is your max minus your min. The biggest weight was 151. The smallest one was 60. No, was 90. That would be pretty... Yeah, unless it's an 8-year-old with a high IQ. That equals 61. So the max interval size is equal to 61 divided by 5, which is approximately is approximately, I got a dead pen. No, no, I don't want you to see on purpose. I'm just kidding. And I think this pen is dying too. I think they should invent pens that never run out of ink. I have one, thank you. I'll put them over there so I don't mix them up with my good one. Okay, the min interval size. How would you calculate that? Tell me. 61 divided by? So our intervals could be anywhere between a width of 3 or a width of 12. What do you think makes most sense? Don't you think 12 is hard to read? Why don't we could use anything, yeah, 10, just use 10. If you can, yeah, just use. If I was doing a histogram of a class marks, what would make most sense for an interval size? Most likely 10, right? Okay, so, yeah, we'll use 10. So we can go 90 to 99, right? 100 to 109, 1110 to 119, 120 to 129, 130 to 139, 140 to 149, 150 to 159. And if you trust me enough, yeah. Now we could use the midpoint of the class. I don't like using midpoint. We'll do it another way. We're just ignore this for now. Okay, if you could trust me on the frequency, it's 2, 3, 4, 9, 9, 2, 1. I don't want to sit here and count. The sum of our frequencies are equal to 30. Our relative frequency is 2 divided by 30 is 0.07. 3 divided by 30 equals 0.1. 4 divided by 30 is equal to 0.13. So it's 0.3. Oh, 9 should be 0.3. 2 is about 0.07. And this is 0.03. And the sum is equal to 1.0. Cumulative relative, we're adding up our relatives, so that's 0.07, 0.17, 0.3, 0.6, 0.6, no, 0.9, 0.97, 1.0. Something wrong? Any questions? We're adding up the relative. That plus that is 0.17. Yes? Yeah, as long as it's close to 1, because you might lose some accuracy. As long as it's close to 1, you just lose accuracy with the rounding. Okay, let's start drawing these. Ready? Wait. Shh. What's wrong? Question? Weight of female students for half a mark. Number of female students for half a mark. Let's see. Right now we're doing a what are we doing here? A histogram. We want a histogram, so that's frequency. So that's going to be 1, 2, 3. Our biggest one has 9, so we'll just go up to 10. 4, 5, 6, 7, 8, 9, 10. And so here, whenever your scale is not regular, you make this symbol. It has a name, but I forgot the name of it. I call it a doohickey. Weight in pounds. So let's just turn it on the side. 90 to 99. 100 to 109. Now they want a histogram, so the bars are closed. This is 110 to 119, 120 to 129, 130 to 139, 140 to 149, 150 to 159, etc., etc. Okay, 90 to 99 was 2. $100 to $109 was 3. 110 to 119 is 4. $120 to $129 is 9. This is 9. After the 9 is 2. And 150 is 1. So what does this tell you? Well, you can see that most of the way, what does it tell you? If they wanted you to draw some conclusions, you could just say most of the weights are between 120 and 139 pounds. We'll just try to finish up these diagrams and then we'll call it a day. Can I explain anything better? No, it's tough. Oh, did they want the on? Oh, that's going to be on the next chart. See how we have charts here? So we'll do that on the next page. Okay. Now, again, now we're doing a relative frequency histogram. So we'll call this weight of female students. So I think to make it easier, we could go 0.1, 0.2, 0.3. I think it just helps in the drawing. So this is relative frequency of female students. And this is weight of female oh, did I put the name of that thing down there? Yeah. This is weight in pounds. So again, we can go, again, we're doing the regular stuff. Don't forget your doohickey, because we're not, there's a jump in the scale. This is 90 to 99. Sorry. Sorry. I'm really struggling as you are in this heat. This is 100 to 109, 110 to 119, 120 to 129, 130 to 139, 140 to 149. I think I'm starting to see blurry, it's so hot. 150 to 159, and that's it. Oh, 160 to 169. Sorry? Oh yeah, there's no one there, that's okay. We just won't put anything there. Okay, so we need our relative frequencies. Our relative frequencies are 90 to 99 is 0.07. So 0.07 would be, that's about a little bit above that, because that's 0.6, that's about 2/3. 0.07 is just a little bit higher than 2/3, right? The next one was 0.1. Oh, that's easy to draw. 0.13 is about there, a little bit below the 1/3. And then we have 0.3. 0.3, 0.07, and 0.03. Let's just finish the comparison and we'll just call it a day then, because this is... Okay, what do you notice about the relative frequency histogram and the frequency histogram? What can you tell me? They look the same. So each have the same shape. They both give you the same they give the same information. Only the scale on the vertical axis is different. Let's call it a day. Sorry, I guess you couldn't see that. There it is right there, okay? Just try the homework, do what you can. I didn't finish the lesson. Usually I finish it in one period, but we didn't. So that's okay, we're almost done. You can do some of the homework. Just do what you can.